Hi everyone, I just wanted to walk through a quick video on the linear programming, show you kind of an easy way to do it, how you can use Desmos to help you get through doing these problems and just make your life a lot easier. So I want to take this one that we did in class and walk through how to do that one in Desmos. So if you go to Desmos and you put in those inequalities, if you press in the lower left hand corner to show the keyboard, then you can put in what those inequalities were. I think the second one was x was less than or equal to 5. The third one was y is greater than or equal to 0. And that last one was 4x minus y, I believe it was greater than or equal to 1. So let me go ahead and put that in. Is greater than or equal to 1. Okay, so you can see, and over here on the right, you can kind of zoom out or zoom in. You can zoom in or zoom out so that you can see the points of that feasible region. And once you do that, once you can see the points, then when you hover over it or when you click on it, it'll give you the coordinates. So I know this point on the top here is 519. I know this point is 0.250. And if I click here, I know this point is 50. Okay, so I can then go ahead and use those points. So I had 519, I had 0.25, 0, and I had 5, 0. So those are the points, those are the vertices of my feasible region. Those are the points that I have to plug in to see. So if I plug the first one in, I have 6 times 5 plus 2 times 19, and that would give me 30 plus 38, which gives me 68. Here I have 6 times 0.25 plus 2 times 0. 6 times 0.25 comes out to be 1.5. And then here, if I go ahead and plug in 5 and 0, I end up with 30. So it's said to find the maximum value of C. It has to occur at one of these points, and it occurs at the point 519, but the answer is the maximum of 68. Okay, so Desmos is going to be really helpful to you for doing these problems. That way you don't have to graph them by hand, and you can just find those points. So let me show you on this example. We've got to find the minimum value this time. So let's go ahead and pull up Desmos, and we'll do those. We've got x plus y, I think it was x plus y was greater than or equal to 6. That was our first one. Whoops. And our next one was, it's less than or equal to 6. Then we have 5x plus y is greater than or equal to 10. Okay, so this should be less than or equal to 6. And then I've got 5x plus y is greater than or equal to 10. And then I had x plus 5y. X plus 5y is, I think it said greater than or equal to, greater than or equal to 14. And then this one I can just x out. Okay, so now you can see that little triangle where those three regions overlap. So we've got 1.5, 2.5. I've got 4, 2, and then if I click up here, I've got 1, 5. Okay, so those are my points. So I've got 1, 5. That was one of my points. And I had 4, 2. That was my other point. And I have this point. If I click on that, I end up with 1.5, 2.5. So I've got 1.5, 2.5. So those are the vertices of my feasible region. And so those are the points I'm going to use to figure out P. So P is equal to 10 times 1 plus 26 times 5. Here P will be 10 times 4 plus 26 times 2. And here P will be 10 times 1.5 plus 26 times 2.5. Okay, so let's figure those out. Let me pull up my calculator and we'll figure those out. So I've got 10 plus 26 times 5. That first one's going to be 140. The second one, 10 times 4 is 40. So I've got 40 plus 26 times 2 is 52. So that second one is 92. And then that last one, 10 times 1.5 plus 26 times 2.5 is going to give me 80. They asked for the minimum value, and so the minimum value I get is 80, so that right there is my answer. So that's all you have to do for these problems. Hopefully that helps you to get through them, but definitely use Desmos. Let that graph it for you. You'll get the points of intersection, and then you're just plugging those points back into your objective function to find the minimum or the maximum depending on the problem. All right, folks, thanks. See you next time.